All right, so this is the 2013 AP Computer Science A question number 4. It's a Skyview class program, but we're going to do it in C++ because I think it's a good program. It's nice and challenging for where we're at in this class. And if you're doing any sort of project, like the end of your capstone project for you might be using two-dimensional arrays. So it says a telescope scans a rectangular area of the night sky and collects the data into a one-dimensional array. Each data value scanned in a number representing the amount of light detected by the telescope. The telescope scans back and forth across the sky, alternating between left to right and right to left in the pattern indicated below by the arrows. The back and forth ordering of the values received from the scan is called telescopic order. The telescope records the data in telescope order in a one-dimensional array of values, double values. So this is like your telescope scanning back and forth, but it's storing them in a one-dimensional array. The one-dimensional array of information received from single scan will be transferred into a two-dimensional array, which reconstructs the original view of the rectangular area of the sky. This two-dimensional array is part of the Skyview class shown below. All right, so again, this is hard to see, but it says private double, and then this is a 2D array view. I don't know. This is too much to read, so let's just go to this one. So part A, write the constructor for the Skyview class. The constructor initializes the view instance variable to a two-dimensional array with num rows, and number of columns. Num calls, columns. The information from scanned is stored in the telescope order. It's copied into view to reconstruct a sky view as originally seen by the telescope. The information in scan must be rearranged as it is stored into view so that the sky view is oriented properly. Okay, so this is the order of it. But we want to get it in this telescopic order, all right? So notice how it goes 0.3, 0.7, 0.8, and then what's in index position 3 goes right here, 0.4, 1.4, 1.1. Okay, so it's going to go this way, then down, and down, okay? So we're going to have, now this is a constructor. We're not doing object-oriented yet, so we're not constructing any objects, but we'll just create a function called Skyview and pass in this 4, 3 scanned. And so this is your scanned one-dimensional array, and 4 and 3 means that there's going to be 4 rows, so 1, 2, 3, 4, even though it starts at index position 0, and 3 columns, 1, 2, and then 3. Okay, so I already kind of started this and created this main 2013 APCSA Skyview. So we need to do what? Let's do our using name space. Okay. And then we'll do our double scanned one-dimensional array. So let's see here. So we got 0.3, 0.7, 0.8, 0.3, 7. Then we got 0.4, 1.4, 1.1, 0.4, 1.4, 0.1. 0.2, 0.5, 0.1. So 0.2, 0.5, and 0.1. And 1.6, 0.6, 0.9. So 1.6, 0.6, 0.9. Okay, so let's think here. We are going to create a void Skyview method, and we are going to pass it what needs to accept it in as int num rows. Oops. Int num rows. Int num calls. And double scanned. So this is us passing in this scanned. Let me think real quick. I think we want to just have this. Instead, let's just put this in here for now. It's not a big deal. I just wanted to pass it in instead of making it a global variable. It's not a big deal. I don't know. I might change it. We'll see what we got to do. So Control C. We'll define our first method. Okay. All right. So we got to kind of figure out a strategy to solve this. So again, we're taking this and then we're putting it in here. So one thing I noticed about this, so this row is 0 and it goes from 0 to the end, but this is a 1, so this is an even row and this is an odd row, and it's actually going backwards. So it's going 4, 1.1, 1, 4, 1.4, 1.1, and then this one goes forward. So if it's an even row, it goes forward, and if it's an odd row, it goes backwards. Okay. So that's something definitely that's important that we need to look at. All right, so I can do Skyview, and then I think for the test, what is it? 4 rows, 3 columns, and we'll pass scanned in, and we'll do a test and just display it in here. All right. So we are going to create a double. Now let me show you this one. So this is going to create a 2D array view, and that's equal to a new double with the num rows. Okay, and so that's how you, again, like, I can't just create a well, let me just look at this real quick. Let me show you. So if I did double view equals new, well, see, I have to give it the number of rows and columns. Let me see, new double num rows, num calls. Let's see here. Yeah, expression must have constant values. So this is the error I'm getting when I don't just hard code a value into the array or 2D array. So I have to define it to give it memory space and it ends up looking like this. All right. So and so what are we going to do here? Sorry, my kid needed me for a second, so I had to pause it. Alright, so this would give us our number of rows, but we still haven't populated our number of columns. So in order to do that, we'll just do a simple for loop. And we'll go for int I equals 0. I is less than the number of rows, I plus plus. And then we'll say view, which is our new it's our new 2D array at row I has you know, this many columns right here. So in this case it'd be 3 columns. Okay, so that sets up the view with the number of rows and the number of columns, and it's dynamic, so you could go in and change, you know, the number of rows or number of columns, however many you needed. Okay, so this is hard coding it right here and just hard coding the data in. All right, so once that's done, so we're gonna have an int scanned index equal to 0, because think about this, we have to as we're throwing in these, we have to have, you know, an index tracker to track where we're at on the scan position so that it can be assigned into the row and column of each of these in the view 2D array. Okay, so I can do a for loop, and we're going to do a for loop on our rows. Okay, so do for, say int row equals 0, row is less than our num rows. Okay, now remember what I said back here. If it's an even row, it's going to go 0 to the end, but if it's an odd row, it's going to go backwards for our columns. Okay, so if row modulus 2 equals 0, so some practice with modulus. 0 modulus 2, the left-hand number is less than the right-hand number, so 0 is less than 2, so it would return the left-hand number, which is 0. 1 modulus 2, 1 is less than 2, so 1 is returned, and 1 is not equal to 0, so 1 would mean that it's an odd number. 2 modulus 2, 2 goes into 2 one time with a remainder of 0, so 0 is equal to 0, and so that's an even number. And 3 modulus 2, 2 goes into 3 one time with a remainder of 1, so 1 is not equal to 0, so that's an odd number. All right, and I'll show you that here. So else, so 2 if it's an even row, then we run our column. Okay, loop. So we'll say int call starts at 0, and as long as our call is less than our num calls, number of columns, call plus plus. Okay, and so we go from 0 to the end of our number of columns. So we'll say right here, we'll say view at the row call is equal to our scanned one-dimensional array at position scanned index. And then we got to add up our scanned index. Okay, so our scanned index is 0 at first, and so for each of these rows, so it'd be 0, our scanned index is 0, then 1, then 2, okay? And that gives us our column, right? And so our scanned index after this first row would be 2, And, you know, then if we hit this one, then we would keep going on and moving over, all right? So that's our scanned index. It's looking at the index position of our scanned one-dimensional array, okay? Else, if we're in an odd row, we would say index, or int call, is equal to num calls minus 1. Because remember, the number of columns is always 1 greater than the ending index position. So this would be column position 2, okay? Because num calls is right here, it's 3. So we'd subtract 1 and we get to 2, okay? Because that's our, you know, look at here, that's index position 2 right there, okay? So then we would say calls, or call, needs to be greater than or equal to 0, call minus minus. And then we can do the same thing right here, I believe. Let me look at that. Okay, so we would just start off at the end of our column at the end, and then go back to position 0. So that would create the serpentine type effect, okay, which is what we're looking for. And then so for this one, this should be done, but again, we always need to test this stuff, so we can just do a for our int, we'll just say rows, I guess. Rows equals 0, rows is less than num rows, rows plus plus, and then for int calls equals 0, calls is less than num calls, calls plus plus, and then we just do what view. We'll do a cout, and we'll say view at rows calls, and then that, and then after each column is done, we go to a new row. So we'll do a cout and end L here. Okay, so let's try this and see if we get okay, 0.3, 0.7, 0.8, and then this becomes the end, so it serpentines through as, you know, my cursor, so to the right and then to the left and then down to the right and down to the left. So 0.4, 1.4, 1.1, then down 0.2, 0.5, 0.1, and then down, and then to the left 1.6, 0.6, and 0.9. Okay, so this looks good. So the view variable 2D array got populated with the scanned information in the serpentine order. Okay, so let's say part A, and that's done. Okay, so let's look and see what part B does. Part B. Okay, that's right. That's where the kids have to write it out on there. Can you imagine? I don't know. All of you are college students now, but I never would have imagined. I mean, this is pretty hard stuff, having to do this at the high school level. So it says write the Skyview method getAverage, which returns average of the elements of the section of the view with row indexes from the start row through the end row inclusive, and column indexes from start call, end call inclusive. For example, if the night sky is a Skyview object with the view where the view contains the value shown below. Call the get average. So 1, 2, 0, 1 should return 0.8. The average of 1.1. Okay, so this is going to give you your row and row start and row end, and then this is going to give you your column start and column end. So start row, okay, I just said row start, whatever, start column. Okay, so we want to be able to read through all of these. Well, not all of them. You want to limit them to where the row starts and where it ends and where the column starts and ends, all right? So that's actually not too bad. So this is going to be what? We want to get the average. So we could do cout average, and we want to what? Get average. And what do we have? An int start row. Actually, I'm just going to hard code it. So I'm going to say 1, 2, because then I'd have to ask the user. So 1, 2, 0, 1. All right, and so then let's see here. All right. So right here we would have double get, and we'll have start row, end row, start call, end call. And so what are we going to do? Return the average. So I need to put this up here. Copy that. Okay. Let's see here. So those are all going to be ints. All right, double get average. Okay. So all right. So we need to have a double average, double sum, or yeah, that's fine. And what, double count? And that could be an int count. It doesn't really matter. I'm just gonna make it double. So let's see here. We're gonna do what? Double view is a 4 by 3, which is equal to and I want to do it like this because I want to show you guys how to populate a 2D array here. Since the goal of this one is just to, get the average. And so I write it out like this because a 2D array is just really a collection of arrays. So 0.3, 0.7, 0.8. So 0.3, 0.7, and 0.8. Notice each array is then comma delimited. 1.1, 1.4, 1.1, comma, 1.4, comma, 0.4. 0.2, 0.5, 0.1, so 0.2, 5, 0.1. 0.2, 0.5, 0.1, so 0.9, 0.9, 0.6, and what was that last one? 1.6. Alright, so there's that. So now we just want to do, just remember the first row to the second row, and then the column 0 and column 1. So that's what we would limit it all on. So then we can do int row equals the start row. The start row, and then row needs to be less than or equal to the end row. Row plus plus. And then we have int column equals the start column, and the column needs to be again less than or equal to the end call plus plus, and then we have our sum variable, so we can say sum plus equals our view at the row and the column. So that should add it up. And then what? So that would give us that. And then each time we want to be able to count the number of times we run through this. So we'd say count plus plus. And then after this we could say average is equal to the sum divided by the count. And then we can return the average. So I think it said, what is the average here? It says the average equals 0.8. So let's run this and see if that's returned here as 0.8, and if we get that right. And we probably need an, shoot, let's do this. Let's do, just before it, we'll do a cout end L. And so we'll go on the new line and not be on the same line as here. What's going on? Let's see if I did something wrong. What's the warning sign? So let's do this here. Let's do cout, and we'll do average in function, and do average. And I might just need to rebuild this thing. I'll rebuild it. Right here. Okay, so I gotta do some more testing and see what's going on. Start row. So we get the average, we pass that in. I mean, am I even getting here? Cout here. Alright, let's try this. Alright, so that's not happening. Cout here too. Nothing's hitting, so rebuild the solution. One failed. Let's see what's going on. Oh. Yeah, okay, so 0.0. It's not really an error. Alright, let's try that now. Okay, one failed. Let's see here. Equals. Okay, let's try that now. Average in function 0.8, average 0.8, here. Okay, so we can get rid of these. And I just want to run this again. That was kind of weird. So again, I just needed to initialize my variables to 0. Forgot to do that. So I don't know. That's good testing for you guys anyway. There you go. So 0.8. All right. So this one works out. You know, we had some issues right here. So you got to see me test a little bit. So I always tell people this. When I was a programmer, my old mentor, when I was struggling and nothing seemed to work, he'd always say, you know, throw a message in. Because you don't ever really know what's happening until you throw the message and display your data to the screen. And so you got to see me throw in data all over the place. And finally, you know, I was looking at the error or the warnings and then figured it out what was going on. So, you know, if you're having issues with your code, make sure you do that, okay? So anyway, this video is done.